guys, my name is Shasvin. Mohnissh RP23028 and Varshan RP23047. So, and I am Shasvin RP2 analysis of car accident at an intersection. So, in this case, the scenario we have is a sedan attempting a left turn at an intersection, collides with an SUV traveling straight through the intersection. The sedan has a mass 1500 kg and was traveling at 10 meter per second. The SUV with a mass of 2000 kg was traveling at a 15 meter per second. Assume the collision is particularly elastic and there are no significant external forces acting during the velocity vectors. In question A, we determine the velocity vectors of the sedan and SUV just before the collision. For sedan, assuming it turns left at 45-degree angle, and the velocity components are velocity x is 10 times cos 45, which gives us 7.07 meter per second. Velocity for y is 10 times sin 45, which gives us 7.07 meter per second. For SUV, which is traveling straight, we can assume it moves along the x-axis, which makes velocity x is 15 times cos 0 equals to 15 meter per second, and velocity is 15 times sin 0, which is 0
Assuming
meter
the
per
parts
second.
of the vehicle ejected upwards upon impact, calculate the trajectory and the maximum height of 5 kg part ejected vertically at a speed of 20 meters per second from the point of impact. So now we can list down the initial speed, which is 20 meters per second, and is going upwards. So we have this formula v equals to square root of 2gh, and then we can just like rearrange it, and we can find the formula for h max, which is the maximum height, which is equals to v square over 2g. So substitute the values inside the formula, we will get 20 meter per second square over 2 times 9.81 meter per second, and the maximum height will be 2.039, I'm sorry, 20.39 meters. Next, for question B is the time taken. We can just substitute inside the formula. T max equals to V naught over G, which is V is the initial velocity, G is the 9.81 meter per second. So which is 20 meter per second divided by 9.81 meter per second, we would get maximum time of 2.039 seconds.
Intensive is forces during collision. Assuming duration of 0.5 seconds, we can find the acceleration by using velocity divided by time. Then, using Newton's second law, we calculate the forces during the collision. Forces on sedan is 1500 kg times the acceleration calculated, which is 20 meter per second. Multiplying this, we could get 30,000 Newton as a force of sedan. Next force on SUV can be calculated from 2000 kg time acceleration, which is 30 meter per second. We could get 16,000 Newton for SUV force.
So
That's
next
all
for
from me.
question D, calculate the total linear momentum of sedan and SUV system just before and immediately after the collision to verify the conservation of momentum. So we have to find total momentum of collision lah. So first we have to find the initial momentum first, which is initial momentum equals to uh, product of mass of sedan and velocity of sedan plus by product of mass of SUV and velocity of SUV. So in terms of x, p initial x, we will have the product of mass of sedan, velocity of sedan in the direction of x, plus by product of mass of SUV and velocity of SUV in the direction of x. So 1500 kg times by 7.071 meter per second plus by 2000 kg times by 50 meter per second, you will get 40,606.5 kg meter per second. That's for initial x. So for initial momentum y, we have the same thing, 1500 kg times by 7.071 meter per second plus by 2000 kg times by 0 meter per second, and this time we will get 10,606.5 kg meter per second. So before we Firstly, we have to find the combined mass of SUV and sedan first. So 1500 kg plus 2500 kg. Sorry, 1500 kg plus by 2000 kg is 3500 kilograms. And once we have this, we can find the final momentum, which is initial momentum in direction x divided by combined mass. We will get 40,605.5 kg meter per second divided by 3500 kg, which is equals to 11.6 meter per second. And the other side, we would get 10,605.5 kg meter per second divided by 3500 kg. We will get 3.03 meter per second. So this is the final velocity of x and y. Uh, Next, to verify the momentum, we would use the formula again. Final momentum is equals to combined mass times by final velocity, 3500 kg times by 11.6 meter per second, which is equals to 40.605.5 kg meter per second, which brings back the same value as before. And the bottom part, 3500 kg times by 3.03 meter per second, which is equals to 10,605.5 kg meter per second equals. It gives us the same value. So from here we can see the momentum is 100% conserved. So let's start with question E. Determine the kinetic energy loss by each vehicle during the collision and discuss how this energy might be transformed to heat, sound, and deformation. So first we have to find the kinetic energy before the collision. So as the formula says, initial kinetic energy is equals to half mass sedan times by velocity sedan square plus half of SUV mass and times by velocity of SUV square, which is equals to half of 1500 kg times by 10 meter per second square plus by half of 2000 kg plus by 15 meter per second square, which gives us 300,000 joules. Next is to find the final kinetic energy, but before that, we have to find the combined mass as we did before is 3500 kg. One more step, we have to find the final velocity also. To find this, we have already listed out as before. Final velocity x is 11.6 meter per second, and final velocity y is 3.03 meter per second. So we substitute inside this formula 11.6 meter per second square plus by 3.03 meter per second square. Square out the answer, we would get final velocity of 11.99 meter per second. So now we can find the final kinetic energy, which equals to half combined mass times by final velocity square, which is half 3500 kg times by 11.99 meter per second square, which gives us 251,580.175 joules. So now we have everything. We can find the kinetic energy loss, which is initial kinetic energy minus the final kinetic energy. 300,000 joules minus 251,580.175 joule, we would get 48,419.825 joules. So you guys probably be wondering how this energy might be transformed into heat, sound, and vibration. Well, in terms of heat, is generated due to the deformation of metal and friction. In terms of sound, the energy is dissipated at noise during the impact. And last but not least, in terms of deformation, permanent bending or crumpling of the vehicle structure. So this total energy loss, again, as we see, is 48,419.825 joules. That's all from me.
Hi
Thank you.
everyone. The next question is question F, which is about non-conservative forces. Non-conservative forces played a significant role in this collision. This includes heat, which is generated due to the deformation of metal and friction, sound, which is energy dissipated as noise during the impact, and deformation, which is permanent bending or crumpling of the vehicle structure. The total energy lost during the collision calculated in question E was approximately 48,419,825. The next question is question G, which is about impulse and momentum change. Impulse is the change in momentum during the collision. For sedan, it's the mass of sedan times by the changes in velocity. Since the velocity changes from 10 meter per second to 0 meter per second, then the impulse of sedan is 1500 kilogram times 10 meter per speed equals to 15,000 newtons. For SUV, the velocity changes from 15 meter per second to 0 meter per second. Then the impulse will be 2000 kilogram times 15 meter per second, which would result 30,000 newtons. This confirms the direct relationship between force, time and momentum change for both. And the last question is question H, which is about post-collision velocity. We calculated the velocity of the joint vehicles post-collision using conservation of momentum. First, we list out the mass and velocity of both sedan and SUV. Then substitute in this formula, which is mass of sedan times velocity of sedan plus mass of SUV times velocity of SUV. After we get this answer, we need to divide this with the combined mass of SUV and sedan. So it's 1500 kilogram times with 10 meter per second plus 2000 kilogram times with 15 meter per second, then divided by 3500 kilogram. We would get the answer 11.99 meter per second, which is the joint velocity. So yeah, in conclusion, we analyze velocity vectors, impact forces, energy dissipation and post-collision behavior. This case effectively demonstrates the application of dynamics principles in real-world scenarios. So that's all from us. Thank you.